So today I'm going to have you guys take these notes over the mole, but the biggest concern about these notes is really how to enter some stuff into the calculator. But other than that, it's pretty simple math. I'll go over it. I also went ahead and I numbered the slides. I want you guys to go ahead and go through each one, copy them, follow the instructions. They're there, but copy them and then make sure that you guys interact with them by going back and highlighting them, circling words that are important. Also, I want you to write at least 5 questions, write them to the side of your notes, where you know that your notes will answer those questions that you've written. Okay. These are the practice problems that you guys are going to be responsible for answering at the end of your notes, and you're also going to have to do a summary with your notes. But these are the calculations that we're going to go over, and I'm going to show you how to type them into the calculator. Okay. Okay, so these are the slides that you have from, these are the questions you have from slide 5, and it's asking how many atoms are in 0.500 moles of aluminum. When you're being asked how many either atoms, molecules, formula units, or ions, pretty much the mathematical process that you're going to do is you're going to multiply. So I went ahead and put that down. Anytime you're going to be asked how many moles, keep in mind that you're going to divide. So what you're going to do for these type of problems is you're either going to multiply or you're going to divide. That's it. So let's take a look at this one. This process where you put the little boxes is called dimensional analysis. This is something that you're going to have to get used to. Okay, so what you do is that you start off with like a grid like this, and you put the given on the first little box. You always want to keep your box underneath the given empty. And then right next to it, you're going to multiply by Avogadro's number, which if you looked at the notes, you would have learned that that's just a unit of measurement. It's for either very large numbers or very small numbers, which in our case in chemistry, that's what atoms, molecules, formula units are. They could be very large amounts or very small amounts. Okay, so in this case, we're going to multiply 0.5 times this number. So this is not a multiplication. This is just the number in scientific notation. If you would have seen the notes. Okay, so as I'm going to enter it into the calculator, I'm going to put that 0.500. And by the way, these calculators, you'll find them in the boxes in the front of the classroom. So it's the same type. You can go ahead and use these over the graphing calculator so that you can do the exact same process. Okay, so if you have a number that's side by side, you're going to multiply. It even rhymes. Side by side, you multiply. So it's going to be 0.5 times Avogadro's number. So it's going to be times, and we're going to put that 6.02. Okay, and we want to get the exponential function. Instead of doing times 10 to the 23rd, there's a button that, I don't know if you could see it right there, but it says EE right here. So because it's in the blue, you're going to have to press the second key, then that, and then it tells you that you'll be typing in the exponent. You don't have to type the times 10. It's understood. All you have to do is type in the exponential value, which is 23. After you do that, you're pretty much set. All you have to do is hit equal. Okay, and as you could see, it says 3.01, and you could barely see it's small, but it says times 10 to the 23rd, and that's exactly how you're going to write the answer. So 3.01 times 10 to the power of 23. In dimensional analysis, the reason we do that is because it allows us to cancel like units. So this is the same, and this is the same. They cancel out. What you're left with is aluminum atoms or atoms of aluminum, and that's exactly what you're going to put. Aluminum atoms. Okay, and as you could see, there you go. So same thing goes with the second example, except this time, notice that Avogadro's number is on the bottom box. So since it's in the bottom box, you're going to end up dividing. And again, it's anytime they're asking you how many moles, you set it up this way, where your given is in the first box. There's nothing underneath the given. Now you have 1 mole of water on the top, and then you're going to divide by Avogadro's number. Okay? So in the calculator, you're going to type in 1.80. Remember, we have times 10 to the 24th, so we're going to use the exponent key. So it's going to be that button, and then that gives us the E. We're not going to type times 10. We're going to put the exponent, which is 24. And we want to go ahead and divide that by Avogadro's number. So divide it by, then 6.02. And then you're going to do, again, the second key, exponent. And the exponent is 23. Equal. And this time around, notice that you didn't have the times 10. This is just a standard number. So I want you to round to the nearest hundredth, which means 2 numbers after the decimal. So in this case, my answer is 2.99. And you've got to put a unit behind it. So it's not just 2.99, it's going to be 2.99. Let's see, we cancel these molecules because they're diagonal and they're the same. Moles of H2O. Okay, so now as you do the assignment, anytime you see how many moles, you're going to go ahead and set up the problem like this. And anytime you see how many either atoms, molecules, formula units, like if it's asking how many atoms, how many molecules, like 2 and 3, those you're going to go ahead and set them up like this. So you would multiply for those and divide for the others. Okay, so that's pretty much your assignment. Don't forget to do the summary at the end, and I will see you guys tomorrow.